Okay, so this video is going to explain a little bit more about rational and irrational numbers, what they are, and the differences between them. So this here gives you a couple of different visuals of something called the real number system. And if you want to know a little bit more about it, you can click that link in the slideshow. Basically, all of the numbers that we deal with in grade 8 math are numbers that are in the real number system. There are also numbers in the imaginary number system and other systems that you'll look at later on in high school. Basically, real numbers are made up of all rational numbers and all irrational numbers. And we're going to look a little bit into a bit more detail about the difference between those two things. So you'll notice this little graphic here has real numbers, and it lists a whole bunch of numbers, and then it splits it into rational numbers, which if you looked at them could be terminating, which means decimals that end, or repeating decimals. Basically, it's any number that could be written as a fraction. And then irrational numbers, which are things that would be decimals that would be non-terminating, that never end, or do not repeat. So for definitions, this is the sort of official definition of a rational number. It's a really fancy definition. Basically, keep it simpler, a rational number is a number that can be written as a fraction. So you can take all of those fancy words and just remember if it's a rational number, if it can be written as a fraction. So that includes your natural numbers, your whole numbers, your integers. It also includes numbers that are already fractions, and then any decimals that terminate, which means they end, and repeat. Irrational numbers, then, are just numbers that can't be written as fractions. Those would be non-terminating decimals, or decimals that don't end and don't repeat. And there's a few examples of both listed. We'll look through some examples as well to kind of help you to understand that a bit better. This also is a graphic that I added in just to help you think through will it be rational or will it be irrational? So if the number is a natural number, whole number, or integer, automatically it's rational. So like the number 4, I could write it as 4 over 1. That's a rational number. Remember, a natural number is kind of the same as a whole number. It's just it doesn't include 0. So natural numbers are the counting numbers starting at 1, 1, 2, 3, 4, 5, 6, 7, etc. Whole numbers start at 0, 0, 1, 2, 3, 4, 5, 6, etc. And then integers are all of the positive and negative counting numbers. What if the number's already a fraction? Well, then it's rational, right? If it's already a fraction, then it can obviously be written as a fraction. So now, where it gets a bit tricky are square roots and decimals. So let's look at square roots first. If the number has a square root sign around it, ask yourself, is it a perfect square? And we have already talked about those things, about what makes something a perfect square. And if it's a perfect square, then it will be rational, because all perfect squares, when you take the square root, you get a whole number or an integer as an answer. So the square root of 9 is 3. It can also be -3, but it's a whole number. If it is not a perfect square, so all of the numbers in between all the perfect squares, then it will be irrational, because when you take the square root of something that is not a perfect square, you end up with a decimal that never ends and doesn't repeat. The final one that's a bit tricky is if it's a decimal. So if the number is a decimal, first thing you need to ask yourself, does it terminate or does it end? Something like 1.36, that ends. That means it's rational. We can write that as a fraction. What if it doesn't end? Okay, so then you ask yourself, does it repeat? Something like 1.44444444, that repeats. That means it will be rational. Or it could be 25252525, also repeats. It can also be something like 2.36666666. So not all of the digits have to repeat, but it does have to have repeating. That would be rational. Something like 3.4555567235, that isn't. So there has to be repetition starting and continuing for it to be rational. If it doesn't end and it doesn't repeat, then it will be irrational. So let's look at a few examples. So the number 5, it's a whole number. It's rational. The number -3, it's an integer. It's rational. The number 1/2, well, it's already a fraction, so it can be written as a fraction. It's rational. 0.3, that's a decimal that terminates. It can be written as 3/10. It's rational. What about this one? 1.2333333. Because the 3 repeats, this is considered a repeating decimal. It's rational. What about this one with a square root? The square root of 25, hey, 25 is a perfect square. The answer would be 5. We already know 5 is rational. This one also has a square root, but it's the square root of a non-perfect square. So if you were to put that into your calculator, you're going to get a decimal that never ends and doesn't repeat. It will be irrational. This one here, notice 2, 7, 4, 6, 8, 8, 1. There's no pattern to that, right? No repetition. The dots mean it goes on and on forever. I'm not going to be out to like trick you. If I have ... it means it goes forever. That one is irrational because it doesn't end and there's no repetition. Now this one's an interesting one that sometimes tricks students. There is a pattern, 1.2, 3, 4, 5, 6, 7, 8, etc. It's a pattern, but there's no repeating pattern. It goes on forever without a repeating pattern, therefore it is irrational.